Hey guys, it's Mr. Sheeline here. This is going to be the video that's going to help you walk through, or it's going to walk you through and hopefully help you understand what this lab is and how to complete it. So this is called the Moving Man Simulation, and we're going to be working with pretty much just constant velocity. Okay, so let's just get right to the objectives. Here are the three things that I'm hoping you're able to do after this lab. One is recognize graphs of position time graph and velocity time graphs where we're working with constant velocity. Okay, so another word is saying it's like you're able to identify, what a velocity time graph, what it looks like when you have constant velocity. Same thing with position time graphs. Which position time graph shows constant velocity, that sort of thing. The second one, determine the velocity of the slope of the position using a position time graph. That one we've kind of done already. The one that it's not too bad, rise over run, and we'll get to that one just not too much longer. Then the third one we're not really going to focus on terribly, but still one to consider. It's determine the distance traveled or the displacement of an object using the area under the velocity time graph. Okay, and that one we'll get to as well. So, okay, materials. So you need a computer, obviously. But not only that, you really should have the physical copy of this lab. So if you haven't already, I'd print this off if I were you. Have the actual physical copy of this of this lab handy, because it's really going to be super useful. If you're not able to, that's fine, but you're going to have to write down all your answers on a separate piece of paper. Okay, which is not a whole lot of fun. The third option, and I'll post a link to how to make your own, Google Doc copy. By making a copy of this lab. You can make your own Google Doc copy and answer everything on the Google Doc, but I don't really recommend this one because you're going to have to sketch out graphs on this, and that's going to be a bit tricky. Okay, so anyway. So those should be added to the materials, arguably. Okay, procedure. So the procedure here, let's just run through this. So what you're going to do is you're going to be using this PhET Colorado lab link that's right here, this blue highlighted thing right here. So that PhET Colorado. So when you click on that and go ahead, and if you're watching this and you're also doing this at the same time, click on that link. And it will take you to a page that has the thumbnail. It'll be like right here, more or less. Click on that thumbnail, and then it'll bring you eventually up to this page. Okay, so once it brings you up to this page, what you're going to do, following step number 3 here, is we're going to hit charts on this lab. So you're going to hit charts. So mine's going to take just a second here. Okay, and we want to use charts because it's going to give us the position time graph, velocity time graph, and also the acceleration time graph. Now, we're really not going to be using the acceleration time graph, so we can get rid of it by pressing this little dude right here. Okay, a little minimize button. And just give me a second, and there it goes. Yours will obviously work a whole lot quicker because I'm doing this on my Chromebook and recording and also having, two of these tabs up at the same time, so mine's a bit slow. Okay, anyway, so we've got those up. Now, for each test. Now, what are the tests specifically? Well, the tests are going to be what you're going to be setting your guide to. The velocity you're going to set them to on this graph here. Excuse me. So that's why I did that. That's aggravating. So what you're going to do is you're going to set the guy's velocity to each of these. So you're going to set them to 1 meter per second, 1.5 meters per second, 2 meters per second, 2.5 meters per second, and then you're going to hit play. Okay, so it's just doing this. So you're going to click on this little box here in the velocity. Okay, and then you're going to say hit 1. Okay, and then once you have that, you're going to hit play, and you're going to watch this guy move across. Okay, move across the simulator. Just give mine a second here, and it'll start going. There it goes. He's going pretty slow right now. What you'll see here is that when you set the velocity, you'll start recording, velocity, time, and also position time. Okay. And what you're going to do is that once it this guy, right before he hits the wall here, right before he hits the wall, you're going to hit pause. Okay. You're going to hit pause right before he hits the brick wall. And what you're going to do is you're going to sketch out what the position time graph looked like. So there'll be this guy right here. And then you're going to sketch out what the velocity time graph looked like, which is this guy down here. Okay. After you have those sketched out, then you're going to hit reset all, and it's going to ask you, are you sure you want to do that? And you'll say, of course. Now that's going to bring your acceleration time graph back up. You can continue to minimize it, or you can just leave it. It's up to you. I prefer to get rid of it because then it's one less thing I have to worry about, and just one thing where I don't accidentally put in my velocity and the acceleration. Okay. So you're going to do that. You're going to sketch your graphs here. Now, when you sketch your graphs, they don't have to be the world's most perfect, beautiful graphs. They can be a quick sketch because the idea is you're going to be using these to answer the questions that are part of this lab. Okay. So you can don't make it super sloppy. Don't make it inaccurate. It should still represent what you see. Okay. You don't need to spend 10 minutes for making every graph here. Okay. Tick marks are great. Numbers are great. They should be consistent as you go down. So when you replicate the X and Y axes, for each graph, it really should be the same. But again, you don't want to spend too much time here because you're just going to later on, you're going to compare and contrast what each of these graphs look like as time goes on. Okay. So then once you have that all done, because that's really the first thing you should complete. So once you have that all done, you're then going to come back up here to analysis part 1, and you're going to start answering the questions using those graphs you just sketched out. So you'll have questions like this, like in each of your velocity time graphs, how does velocity change with time or to time? So in each of them, look at your velocity time graphs. How do they change? As time goes on for each of them, what happens? Okay, and then tell me what you see. For number 2, referring to your table, what happens to your velocity time graphs? Is the velocity increase? So you're comparing each of them. So does velocity increase when you set velocity to 1.5 meters per second? Does it increase when you set it to 2 meters per second? Okay, so it's like asking collectively, does velocity increase when you set your velocity? You could also answer it, individually. What does it look individually when each time you increase that velocity, do you notice anything different? Okay. Number 3, as velocity is increased in your table, how does each of your position time graphs change? So what is changing? Use your math words. Specifically, what is changing in your position time graphs? Okay, what is the difference between them? For part 2, so here you're just going to play around with that fourth setting. When you set the guy to move at 2.5 meters per second, okay, you're going to run it right before he hits the wall, and you're going to record the distance and time traveled, okay? And then you're going to be answering these questions down here. Calculate the slope of the position graph. And when you calculate it, how does it compare with the man's velocity? What do you see that's the same? What do you see that's different? And then given the results of A above, write the expression for velocity in terms of time and distance. So you really already have this. What expression could you write? Or more specifically, what equation could you write that shows how you can find velocity using a velocity or position time graph? Okay. And then using a velocity time graph, calculate the area under the velocity time graph. So this is where that third point is coming in. Okay, that third objective. So here, think of it this way. Okay, the area underneath your velocity time graph. So if this dude, if he'll go, this will work quick enough, which actually probably won't. Here, so I'll write this out. I'll draw this out on here. So if your graph looks like this, okay, if your graph looks like this, oops. Come on, eraser. So if your graph looks like this, and you've got velocity over here, and you've got time down here, And let's say you set it to 2 meters per second, or that 2.5 meters per second. And this guy, you allow this guy to move at 4 or until about 4 seconds. Okay. Roughly speaking, your graph is going to look something like this. Okay. It's going to look something like this. Now, you tell me what this looks like. What this looks like to me, that looks like a box. And you know that the value of that box here, okay, you've got 2 on the side, you've got 4 below. How is it that you find the area of the box? It's just length times width, okay? So when you hit the length times width, you're calculating the area of your graph, okay? And then you're just saying, and then it's questioning, how does the area you calculated compared to the distance the man traveled, okay? Using a VT graph. Arguably, it's and you can, in order to find, displacement, it'd be like this. It's like, oh, well, displacement we know is equal to, okay, D's up top, so it'd be like velocity, okay, it'd be like velocity times time. How does this compare to this? That's what it's asking, okay? So answer it. How does it compare? What do you see that's different? What do you see is the same? And then B, given your results from A, write an expression for the distance, really displacement, in terms of velocity and time. So again, what have you seen, like literally just 5 seconds ago, that would express how we can find displacement using a velocity time graph, okay? Okay. And then now there's going to be the part 3, and part 3 is kind of for funsies, but it's still asking you, it's still questions to actually answer. So now this is part 3. So find a way to make the man move left. So you're going to tell me, what did you do in order to make the man move to the left? So it's like this. So when you plop in your velocities, you're going to notice that this guy's only really going to move to the right. So tell me, what did you do to move the man to the left? So just briefly tell me here. And then what you're going to do is that whatever you set his velocity to, show me what the position time graph looks like, okay? Tell me what his velocity time graph looks like when he does that. And then what you're going to do is that after you sketch those out, you're going to then tell me, how does this differ from the graphs you sketched in the table? So how does it look different from the ones that you showed in the table down here? So when you get these after you get all these sketched out and you've answered all the other questions, and after you get these sketched out, you're going to compare these two with what you see down here. Okay, that's pretty much it. So anyway, so that's pretty much the walkthrough, guys. So if you have any questions for me, make sure you ask. Make sure you send me an email send me an email on Gmail. You can ask me through Google Classroom. You can send me a remind. If there's something you're really struggling on here, we could also do a little Zoom meeting, a little Google Meet to answer any questions if you desperately need that help. Okay. So you're going to be, we worked on this in class today, but we also, you're going to be working on this at home tonight and tomorrow. So, and then we're going to be doing virtually the same lab on on the next in-person day. But it's going to be a lab where we're going to include acceleration in as well, constant acceleration. And we're going to be looking at that more than anything. Okay. And I'll have a video up for that as well. So that's the video, guys. Get a hold of me if you have any questions. If not, I'll see you in the next one.